right, 8.1 part 2. Okay, so we're starting with f of x equals x squared. That hasn't changed. There's still no other numbers. That's our base graph right there. F of x equals x squared. There's our basic parabola. Okay, let's see what happens when we type in a bigger number in front of x. Let's say 4x squared, 5x squared, 4x squared, whichever one. 4x squared. And notice how it gets a little skinnier. All right, I want you to think about this. What happens if I put 8x squared in there? What'll happen? I want you to think about that on your own. And it's even skinnier than 4x squared. Right? What happens if we throw a 3x squared? I want you to think, which two lines will this graph be in between? We have 3x squared, right? We have it right in between that x squared, our basic graph, and our 4x squared graph. Okay, so as the number goes up, the skinnier the graph becomes. The number goes down, the wider it becomes. So what happens if we go less than 1? Let's say 0.5x squared. Okay, it gets even wider than 1. What happens if we go 0.25x squared? What's going to happen there? Right? Even wider. It's even lower than 0.5, so it's going wider. What graph, where will this be if we say 0.3x squared? Where will that graph be? What two graphs will that be in between? Right between that 0.5x squared graph and our 0.25x squared graph. Right? That makes sense. Okay. Let's talk graphing. Okay, let's try to graph one of these. Let's just say, let's try to graph on 2x squared. F of x equals 2x squared. Okay, let's say we were just given this right here. We had to go and mark this on our graph. Our vertex hasn't changed. That's still at 0, 0. So we have x and y. Okay, I'm just going to make a graph here. We have 0 and 0, right? This point is at 0, 0. That's our vertex. Well, we have a positive x and a negative x. That's a 1. Okay? So let's try to plug this into our graph of 2x squared. When our x is equal to 1, what we have is 2 times 1 squared, and that will equal our y, or f of x. F of x or y, they're the same thing. What's 1 squared? That's 1. So 2 times 1 equals y. Y equals 2. So when x equals 1, y equals 2. So let's put that on our graph. We have 1, 2. What happens if we say negative 1? Y equals 2 times negative 1 squared. Well, negative 1 squared is just positive 1. Negative 1 times negative 1 is 1. And 1 times 2 is 2. So at negative 1, we're at positive 2y. Okay, do we really even have to do the math there? Well, we don't, because this is a perfect axis of symmetry right here. And whatever goes on one side of the axis of symmetry has to go on the other. So if at 1 is 2, and negative 1 it also has to be 2. Okay.